In the previous videos, we looked at the fact that if you take a circuit, an electronic circuit, and you apply a voltage across the circuit, which is sinusoidal, and let's say signal, the forcing function here has a form Vm cos omega t plus theta. Okay, then the current that you get through the circuit is going to be Im cos omega t plus phi, right? The phase has changed, the amplitude has changed, but the frequency remains the same. Let's call this some circuit, okay? Now, if I change the time reference to this circuit a little bit, and here's what I'm going to do. So this is the same circuit, but instead of giving as a voltage input a cos function, let me try to put a Vm sine omega t plus theta. Okay, if I do that, what is the output going to be? The output, the current, is also going to be Im sine omega t plus phi. So basically, this has been shifted by pi by 2, and this also has been shifted by pi by 2. And so they become the sine signal. Now let me do an operation which cannot be performed in the lab, right? I can give a cos wave, I can give a sine wave, but right now what I'm going to do is I'm going to give an imaginary signal J to the circuit. Now this cannot be done in practice, right? Because there is nothing called an imaginary signal. But mathematically I can do it. So if I give an imaginary signal and this is a linear circuit, what will be the output? It's also going to be an imaginary signal, isn't it? Okay. So now here's what I'm going to do. Again, we are assuming that these are linear circuits. So here's what I want to do. I want to take this circuit. Okay, and this is the same circuit as before. And I want to give an input to the circuit, a sinusoidal input. But now the sine wave input that I want to give to my circuit is the addition of these two inputs, Vm cos omega t plus theta and J Vm sine omega t plus theta. Okay, so it's going to be, so the input is going to be Vm cos omega t plus theta plus J Vm sine omega t plus theta. Okay, so if I do that, what is my output going to be? My output is going to be the sum of the output here plus the sum of the output here, right? So my output is going to be Im cos omega t plus phi plus Jim sine omega t plus phi. Now, of course, if you remember your complex numbers a little bit, and you would easily see that the function that is here is a complex exponential, isn't it? It's basically Vm e to the power j omega t plus theta. And when I give that input, the output that I get is Im e j omega t plus phi. Okay, so the real part of this complex exponential is the input that we were looking at to give to a circuit right at the beginning here, right? And the real part of the output is the output that we are looking for here in this circuit. So is it possible that our circuit analysis becomes easier when we input a complex exponential and look at the output corresponding to the complex exponential, rather than giving a cos function and looking at the output? So that's what we're going to look at in the next video.